Hey everyone, and welcome. Today, we're going to pull back the curtain on something you've probably seen a million times, but maybe never really thought about. That clear bag of fluid you always see hanging by a hospital bed. I mean, you have to wonder, right? When someone's really sick or just out of surgery, what's inside that simple-looking IV bag is, well, it's one of the most critical parts of their care. And believe me, it is so much more than just water. You heard that right, the electricity of life. Now, I know that sounds incredibly dramatic, but if you stick with me for a few minutes, you're going to see just how true that really is. So let's start by looking inside this little medical marvel. What exactly makes it such a lifeline? Doctors use these solutions for what's called fluid and electrolyte therapy, and it's really a two-part mission. Sometimes it's just for maintenance, to keep all the body's systems ticking over smoothly. But other times, it's about replacing serious losses of fluids and these absolutely vital electrolytes. And that brings us to the big question, doesn't it? What in the world is an electrolyte? And why on earth is it so important that we call it the spark of life? Okay, so this right here shows the fundamental difference. On one side, you've got an electrolyte, like simple table salt. When you drop it in water, it completely breaks apart. It dissociates into these little charged particles. But on the other side, you've got a non-electrolyte, like sugar, which you'll often see called dextrose in medicine. It just dissolves, but it stays as one single uncharged molecule. And that ability to carry a charge, that, my friends, is the secret sauce. So here's the formal definition, the key takeaway. Electrolytes are substances that, when they dissolve, create these electrically charged particles called ions. And you know their names. We're talking sodium, potassium, and chloride. These aren't just letters on a chart. They're the tiny charged workhorses that literally run your body. So think of electrolytes as the ultimate project managers inside your body. They're controlling all the fluid levels, they're regulating your metabolism, they're standing guard over your internal pH balance. And maybe most importantly, every single nerve impulse and every single muscle contraction, from you blinking your eye to your heart beating, all of it is powered by the electrical signals they provide. So if electrolytes are all about that electrical charge, how do we actually go about measuring that power? It's not as simple as you might think. And this is a really key shift in thinking. When a pharmacist or a doctor is putting together an IV solution, they're not just thinking in terms of grams or milligrams. Nope. They're thinking about the electrical punch that each one of these substances packs. And the special unit for that is called the milli equivalent, or MEQ for short. It's just a way to measure the true chemical combining power of an ion. It's not just about whether it's there, but about the strength of its charge. Okay, look at this example. It makes it super clear. Calcium chloride doesn't just split into two particles. It actually splits into three. You get one calcium ion that has a positive 2 charge, and you get 2 chloride ions, each with a negative 1 charge. The milli equivalent value is what captures that entire electrical picture, which you can imagine is way more useful in a hospital than just counting molecules. All right, so we've got the electrical charge down, but these tiny particles also create another incredibly powerful force in the body. Physical pressure. Let's take a look at how that works. The key process here is something you probably remember from biology class, osmosis. And you can think of your cell membranes as being like these really picky gatekeepers. They let water flow through, no problem, but they're way more selective about the bigger particles dissolved in that water. Exactly. Water is always trying to balance things out. So if one side of a membrane has more particles, more electrolytes, more sugar, whatever, water's going to rush over to that side to try and dilute the concentration. It wants to even out the party. And that powerful movement is what we call osmotic pressure. Now, to measure this pressure, we use two terms that sound almost identical: osmolarity and osmolality. The really technical difference is just whether you're measuring particles per volume of solution or per mass of the solvent. And while scientists have to be super precise about that, for the really dilute fluids inside our own bodies, these two values end up being pretty much the same thing. And this is the magic number. The normal osmolality of our blood serum stays in this incredibly narrow range. Your body works tirelessly, 24/7, to keep it right there. If you go too far outside this range, either way, you are in serious, serious trouble. So let's bring this all together. How does all this science, this stuff about electrical charge and osmotic pressure, actually allow doctors to restore patients' critical internal balance? Well, life happens. Whether it's a nasty stomach bug, sweating a ton during intense exercise, having kidney problems, or recovering from surgery, There are just so many ways we can lose water and electrolytes and throw our whole internal environment out of whack. And this is the moment when that IV bag becomes a true lifesaver. And keeping that balance is tricky because our body isn't just one big bag of fluid, right? Different ions are concentrated in different places. You've got sodium and chloride as the main players outside our cells. Meanwhile, potassium and phosphate are the big bosses inside our cells. And maintaining that separation is absolutely vital for everything to work correctly. So how do doctors get a quick snapshot of this super delicate balance? Well, they can use a formula that looks something like this one. Now, don't worry, you do not need to memorize this. Just think of it like a diagnostic dashboard for your car. By plugging in a patient's blood values for key things like sodium, potassium, glucose, and something called BUN, which is a measure of kidney function, a doctor gets a really precise estimate of the body's total osmolality. And that tells them exactly what that patient needs. It's a carefully crafted cocktail designed specifically to restore that fundamental electrical and chemical balance that is, quite literally, the spark of life itself. Pretty amazing stuff. Thanks for tuning in.